Big hello again from the Tin Man. First thing I'm going to say is, if you're a avid Bedini lover and believe what he says is gospel, then you're probably better off to go and watch another video. If you really are into experimenting rather than replicating, I advise you to watch this, because we're going to go through the SSG motor or pulse generator, whatever you want to call it, and break it down a bit and see what's actually happening in the circuit. So the first thing we're going to do is have a look at the waveform. It may be a bit of a misconception that if you have all your norths out or all your souths out, you're going to get a DC pulse to the transistor. Well, that's not the case. Doesn't matter which way you orient your magnets, whether it be all south, all north, or north, south, you will always get an AC wave generated in the pulse coil. So I've got it hooked up to the box of tricks there. It's set on the AC scale. So if we just give this a little spin, you can see right there that it is an AC waveform that it produces. Now I've got the probe hooked up between the end of the trigger coil and the base, which is eventually minus your resistor and your pot, the two ends of the coil. So as you can see, you get an AC wave from the coil, even though all these magnets are the same polarity out, which is all south. I will never put north out, as a lot of you would be finding you're having a lot of trouble with it magnetising the core of your coils and your efficiency is dropping down. So what actually happens is, with all your north out, as the rotor approaches the coil, sends a positive charge up the end of your trigger windings and back through your pot and back into the start. Now one of three things is happening here, and they're all bad. We now know that it's an AC current and not a DC current that's going through the windings on this. Now what happens as your magnet approaches the trigger windings, or your coil, sends positive charge up here. Now you'll notice the first thing it comes across is the negative side of a battery. Now I don't know what you think, but an AC pulse into the negative side of a battery can't be a good thing. So what we're going to do now is actually measure to see if there really is a charge of the opposite polarity going in to our run battery. So I'm going to disconnect the scope. Now this meter here is hooked up to the charge battery. This meter here is our amps that the motor is drawing from the run battery. This meter here we're just going to use to see if there is any current between here and the negative side of the battery. So to get any indication on the meter, if that's the case, if it was a negative charge going into the negative side, we would get nothing. If it is in fact a positive charge going into the negative side, it will show up on the meter. So set your meter to AC, because we know we're getting AC from the coil, not DC. Going to grab our probes here from that meter. Now I'm going to hook, what I've done is disconnected the meter from the emitter, or the coil from the emitter. I'm going to hook that up to one side of the meter. Like so. So now we have from the emitter into one side of our meter. The other side of our meter, we're going to hook up on the other side, which will be the base. So find myself a lead. So put that on. Sorry, I'm going to put that on the end of the trigger coil, and the other end is going on to our earth side of the battery, which I've got hooked to the emitter. So what that's going to show us is if there's any AC voltage going into the DC negative side of a battery. Oh, look at that, 1.5, 1.4. So that's a bad thing. Just at that low speed we had 1.5 volts of positive charge going straight into the negative lead of the battery, the run battery that is. Now that can't be good. The other thing that happens, if that's not happening, which you can clearly see it is that charge goes through there, through resistor, through the pot, back in there. Now we all know what happens when you short a coil as the magnet approaches. You get a back EMF and it wants to push the flywheel in the wrong direction. So that's two bad things that happens. The third thing that could be happening is the charge is coming off there. If it does not going through to the negative side of the battery, which you've seen that it is, and if it's not going through here, what happens is it's firing up the transistor, which you don't want before the magnet gets to the coil, if all your magnets are north out, like most people do. So I'm going to show you how to fix that, and there's going to be two improvements when we do that. So what we'll do is disconnect that. I'm going to hook the emitter back up to the coil as per your standard SSG pulse motor. Okay, so like I said, that's our charge battery. I'll just put that on there so we can see that it's charging. That's our amp draw from the run battery. So I'm going to show you how to fix this problem, and you do it like this. Two diodes on your trigger coil, like so. This still remains the start of your trigger coil, which goes to your pot. The end becomes the negative side of the two diodes. This side you no longer use. That's how I've set this up, and I've got a jumper on there so we can go from one to the other, and we're going to show you how much the amps drop down when you do it like this. We're also going to show you the effect that it has on the radiant energy coming off the coil to the charge battery. Now as you can see here, I've got three neons hooked up. This is because the way that I wind my coils, as you would have seen in previous videos, I get a very high voltage on the back spike, a lot higher than a bifilar wound coil. So we've got three 110 volt neons hooked up in series. If I have only one, it blows it to pieces. The other thing I've done is taken the pot out, put a 600 ohm resistor in, so none of that can change. There'll be no turning the pot up and down to get different results. It's set. So what we can do now is start it up. Now because I can't wind the pot up and get it going quick and then wind it back down, have to wait a little while for it to build up speed. As you can see, our charge battery is starting to trickle up already. 54 milliamps, 55, and it'll go up until it's settled at its speed that it wants to run at with that resistor in it. So what I'll do now that we're not using this meter, I'll hook it up to the charge battery, or the run battery, sorry. The run battery's got 12.56 volts in it. Oh, we're nearly up to speed. I hope you guys can see that little meter properly. Play the game. So far we've worked out, even if your magnets are the same, you still get an AC waveform. And we've also discovered that we're putting a positive charge straight into the negative side of the battery, which is definitely not good. Okay, so now we're up to speed pretty much. If you can see that. Take that away. We're drawing 63 milliamps. Okay, so what I'm going to do now, it's hooked up as per the normal SSG at the moment. I'm going to take this lead here off, which is the end of your trigger. I'm going to put on the back side of the two diodes, which I have here. And I want you to watch the amp draw on the pulse motor. So we're at 65 milliamps now. Taking it off, hook it on there. Look at that, 55 milliamps. Drop 10 milliamps off the current draw. So now the other thing we're going to do is test to see what that has done to our voltage spike going into the battery. Charge battery, that is. Okay, like I said, I've got my 3 neons hooked up in series, 110 volts each. So it's a total of 330 volts going through them. I'll disconnect the charge battery. Now I want you to take notice of the brightness of these. So this is hooked up as per normal SSG. As you can see, there's a little green one there because I ran out of clear ones. They light up. So we know we're getting our high voltage spike. Now I'm going to take the trigger wire from there and put it on the back side of the two diodes. This eliminates voltage going into your negative side, which is why the voltage draw drops on that when I do it by 10 milliamps. Now the other thing that happens, so I'd like you to watch the brightness of the globes now when I disconnect the charge battery. Oh, look at that. Okay. Normal SSG hookup. They light up. Hook it up this way. Voltage driving the motor goes down. Neons light up a whole lot brighter. So there you go. Normal with the diodes. So what you've actually done there is you've split this coil into two half-wave AC pulses. Now the half-wave AC pulse going into our negative side is the one we don't want, so we eliminate it like that. The only one you do want is the other half that goes through here, fires up the transistor. So that's one improvement we've made to the SSG. And as you're seeing there with the scope, we get an AC waveform no matter which way the magnets are directed. The only difference is when you have magnets oriented north-south, north-south, if this is our 0 volt line on the AC wave, you'll get the magnet approaching the coil will give you a wave like that, leaving the coil gives you a wave like that, and then back down to 0 volts. With north-south, north-south, when the next magnet comes around, the wave will start on this side and peter off like that. So you'll get a double bump each side of the AC wave. So that's just my first video that I'm going to do in a series of 3. So like I said, normally that's how bright the lights are. Hooked up this way, you get no voltage going back to your run battery, which of course has helped flattening your run battery. Hooked up this way, your voltage spike going into your charge battery is much higher. So there's 2 faults with the way Bedini sets them up. Now like I said, if I can find my compass, where have I filed that? All my magnets are south out, not north. This eliminates your core becoming magnetic. And also this way, when your magnet approaches the coil fires up, and once the magnet is in line with the core is when your coil switches off. The fastest way to pull down a north field in a coil is to have the south magnet right opposite the core when it switches off. That is one of the other reasons you get such a high voltage coming back into the charge battery from this setup. So it's a combination. South is magnets out, eliminates your core becoming magnetised, also pulls the magnetic field down a lot harder when the coil switches off. And then if you do this, you're going to lose some of the power or current draw from your run battery, and you're going to increase the voltage spike going to your charge battery. So on my next video we're going to go through the coil bit by bit, show you how I've wound it. The flywheel, I'm going to make 2 more of these up with all north out, all south out, and north south, north south, so we can see the difference. So hope that's helps some of you guys out that like experimenting rather than just replicating. It's just a couple of improvements you can make to it so far. There is more which you'll see in my other videos to come. So like I said, if you're a avid Bedini fan and believe what he's saying is the best and only way to do it, well, I'm a little bit sorry. The way he set it up is a little bit inefficient. It's a good starting point, but once you've gone there, start to understand how things work, I suggest go into experimenting with your own setups. This system here no doubt could probably be improved on some more as well. Like I said, I aim to get the most out of the motor itself. So far I've shown you how to drop your current draw on your run battery, how to increase your voltage spikes at the same time to your charge battery, and also the reason why you should have all your magnets pointing south out is because it stops the core becoming magnetised. The core will pulse north, and then you'll get the south field of the magnet passing the same amount of time, so it keeps the core of the coil neutral. No matter what material you use, it won't become magnetised. Soft iron is the best to use, but unfortunately with all your north facing out on your magnets, it will become magnetised. The efficiency of your motor will drop down drastically, probably to a point where it won't run. So put your magnet south out, so you got coil firing north, magnets passing south, keeps the core neutral. Hook it up like this, decrease your amp draw on your run battery, drastically increase the pulse voltage to your charge battery, as you would have seen with the different brightness in the lights. Okay, till my next video, happy experimenting and bye from the Tin Man.